Yeah.
Let me find the right screen. Should be this one.
Good, great.
Okay. You can see it now?
Yes, I see it.
Okay. Okay. So today I'm going to tell you a little bit about Lumberjack. It's a logging library for the Angular framework. I won't go too much into the Angular details, but I will tell you about give you an idea about the features of Lumberjack, and we'll look into our CI workflow on Github Actions. And we'll discuss the design decisions we've made for this library and why the cross-version Angular compatibility is important and why it's difficult to deal with and how we solve it. So first, let's look at a few of the features here. It's a logging library. It has 6 different levels of severity for the logs. It has a plugin-based architecture. And the reason for that is this is not a logging library focusing on making beautiful colors in the console. It's a logging library which you can plug in different drivers for various log providers. So we're trying to build a stable foundation, and then we welcome and support community-driven log drivers for Lumberjack to connect it with different log providers. And because we sit between the application and the log drivers, we also have some robust error handling. For example, if one of the drivers throws an error when we're passing it a log object, it will be transformed into an error log object that will be passed to the other active log drivers. Lumberjack comes with 2 built-in log drivers, one for the browser console and one for an HTTP log driver, which is a simple HTTP implementation. It sends 1 log object per HTTP request to an endpoint in your backend that has to implement, accept a request following our TypeScript interface. Lumberjack comes with some declarative logger-based classes that we'll look at later. And it also has a more imperative Lumberjack service that you can pass object literals representing the logs. There's also some log builders for convenience, and they're also helpful for tests, or if you have more of a programmatic imperative flow with some generic code, for example, or very dynamic code. We also have Angular Schematics. That's a special thing in Angular that you can add, it's called an ng-add schematic, the one we have right now. That means when you install this library using the Angular CLI, it will also configure the library so that it's registered with Angular, so you can use it in your application. So it's a bit of a post-install hook that goes and modifies the code of your library or your application to add Lumberjack to that application. And most importantly, it also has Lumberjack has verified cross-version Angular compatibility, meaning that we support 8 different versions of Angular, and we have them all tested for every commit in our repo. The Lumberjack service, Angular makes heavy use of classes and decorators. They have the concept of services that can be added to, for example, a component through dependency injection. So this is one of those, the Lumberjack service. It has one method called log, and we pass it a Lumberjack log object that has some properties. It also has a generic type parameter, tpayload, and this can be left out, or you can, as a user or as a developer in the application, you can specify which properties you want to add to the log object. So you can add any payload that will be shipped to your log provider. Of course, that log provider has to support those properties, but it's up to you to define what you want to add here. The Lumberjack service is used like this in Angular. So in the constructor, Angular uses dependency injection, which means that it's TypeScript also, by the way. Hope you're familiar with that. But we're asking here for the Lumberjack service, and we give it the Lumberjack service type. Then Angular knows how to new up that class and pass an instance to us. And the second and third highlights, you see how it's used. We call the log method of the Lumberjack service, and we pass it an object literal that has these properties: the created at timestamp, the logging level, the log message, and an optional scope, which can be anything what you decide. It can be a service or the name of a component or a feature of your application or the name of your application or anything you want to group those logs in your backend. We also, when using it imperatively, we should also inject the Lumberjack time service. So that's for testability, because then we can replace and control the timestamps in unit tests. So if you want to have an easier time or very high level of control of your unit test, you should inject the Lumberjack time service and replace that in your tests. There's a way around this that makes it a little more convenient. We'll look at that later. This is the Lumberjack Log Interface. So that's what we saw before: created at level message payload, the optional one that you decide which shape that object should have, and then the optional scope we also discussed before. And again, this generic type parameter, which is the shape of the payload. We have these, there's 7 levels. That's because one of them is verbose, which means activate all the logging levels for globally or for one log driver. So the log objects themselves can have the 6 of these: critical, debug, error, info, trace, and warning. And verbose is only for configuration of Lumberjack and log drivers. So let's look at this plugin-based architecture. In an abstract way, it looks like this. We had that hero service from before. It calls Lumberjack Service, and that passes control on to the activated log drivers. Here we have the built-in ones activated: the console log driver from Lumberjack and the HTTP log driver from Lumberjack. The flow of dependencies is especially important since we have this plugin-based architecture. So again, your hero service is depending, or your parts of the application depends on Lumberjack. And the drivers will implement this interface called Lumberjack Log Driver. And Angular has a thing called an injection token that represents services you can provide. It's called providing a service in Angular. That means you can register your driver with Angular and say, you should hand this over to any class asking for this dependency injection token. So if we were to add a third-party log driver to our application, the control flow will still look the same way, but we would pass control to a third-party log driver. For example, we have an Azure Application Insights log driver created by the community, another one for Firestore. Yeah, if you want to create one, we have several ways of supporting you. So please ask us about that. The flow of dependencies also still is in the way that the arrows of the dependency arrows are always pointing towards Lumberjack. So Lumberjack sits conveniently in the middle of everything in full control. The log drivers depend on whatever interface Lumberjack tells them to implement and respect. And the application is also at the will and mercy of Lumberjack. Well, we have a way of making as few parts of your code depend directly on Lumberjack as possible, and we'll also get into that a bit later. But this is what we want to have a plugin-based architecture. Dependencies are pointing inwards towards Lumberjack, and no arrows or no dependencies pointing outwards, with the exception of Angular, of course, since this is a logging library specifically for Angular. So if you're not familiar with Angular, this will look very weird and strange, but Angular has this concept of Angular modules. It gives instructions to Angular's compiler about how to bundle and compile your application. So we have this class called an app module. And that's one of the places you can register, for example, these services that you want to use in your application. So the first thing you'll want to do is import the Lumberjack module from the package add ngworker/lumberjack. We call this static for root method. That's a conventional pattern in Angular, which means that it should only be used or called in one place, usually in the class called app module. We have this console driver is in a sub package. So if you don't want to use it, it won't be included in your application bundle. So that is registered in the same way. It has a Lumberjack console driver module with a static method called for root. So by calling this method, the Lumberjack console driver will be activated, and you don't have to change your other places in your application code. This is the only place you mentioned the console driver. Similarly, we have the HTTP driver here, and if you look at the highlighted part with the module, it says with options. So it has some required options, the origin, some retry options for retrying the HTTP calls or requests if they fail, just to have a somewhat realistic implementation. This is meant primarily as a reference log driver if people want to see how to implement their own log drivers, but it is also working in production. So it's very simple because we didn't want to add complexity. We wanted a nice, clean implementation for people to refer to when implementing their own log drivers. We have the built-in log drivers. We have some third-party log drivers created by the community, but you can, of course, implement your own custom log driver for your organization or your project, and it's relatively simple to do so. There is an interface, looks like this. It also has the Lumberjack generic for the payload. It has the config property, for example, with the logging levels, so that they can be filtered for this log driver. And then there's a method for each log level, the critical level, debug, error, info, trace, and warning. And each of those methods accept a driver log object. And that looks like this. It has the formatted log. So that's the text representation of a log object. And then the full log object, so that the log drivers have all the data that's passed to Lumberjack, and they can take whatever they need and process the data in any way they feel is necessary. On the other hand, you can use the formatted log. We do that for the console log driver. So you would get something like this in the browser console. But this formatting function used to process the log objects can even be customized if you want a different format. By default, Angular has two modes of execution, one called the development mode and one called the production mode. When Angular is running in development mode, all the log levels will be enabled by Lumberjack. When running in production mode, the debug and trace levels will be disabled, but users can, or application developers can override this setting, of course, if they want to always add all log levels, for example, or just some of them. It can even be configured per log driver, and it looks like this. Here we're saying that for the console driver, we use the verbose configuration, which means activate all the log levels for this driver. And for the HTTP driver, we're saying we only want the critical and error logs shipped to our log provider backend. The next thing we're going to look at here is we had a problem. We figured we were only using a small portion of the Angular API. So we figured we might try to support many versions, major and minor versions of Angular, to make it easier for our log drivers to keep up and for applications to maintain their dependencies. Because we don't expect Lumberjack itself to change very much. We took all the important breaking changes and created a version 2.0 that was released recently, so that we can have a stable and long-term major version of Lumberjack. And then the log drivers can say we support Lumberjack 2.0 and we support version, for example, version 2.5 of the application insights library, which only supports version 11 of Angular. So the puzzle becomes a little bit easier when we have just one version of Lumberjack for a long time, as long as possible. But we use GitHub Actions to solve this. The problem we want to solve was these 8 versions of Angular. Angular has its own compiler on top of the TypeScript compiler. So it's tied to every minor version of Angular is tied to just 1, 2, or 3 different versions of TypeScript. So not only do we have to test our package with many different versions of Angular, but also the TypeScript versions that are very specific to that particular version of Angular as well. And I know Mark Whitfield knows about this. Additionally, we're also testing with the 2 major versions of Node.js supported officially by Angular, and that's 30 possible combinations of dependencies. So how would we solve this if we wanted to test every possible combination? We could create one project per combination of dependencies. Then we would have 30 application projects, each with their own package.json file, and we would have to keep the source code of those applications in sync, and the test suites for those applications keep them in sync as well. That's one way to go about it, but we figured that was a lot of maintenance for a relatively small library. So we came up with a solution. We're using the Angular CLI for this. It supports multiple projects, which means you can have more than one application in an Angular CLI repo. So we have one demo application, as we can see here in the image. We have an end-to-end test suite. It's using Protractor. On top of that demo application, we have a Schematics app that was the code generation supported by Angular CLI, which will set up the configuration of the Angular modules we saw earlier for the drivers and Lumberjack itself. So we're also testing our schematics, which is Node.js code. And so when we're doing that, we're targeting this schematics app project, and the tests themselves are in the schematics E2E end-to-end test project. It's using Jest to run commands in the console through Node.js, and then it's verifying what happened after running those commands when targeting this application project. So we have a single code base, the same source code files for the application, the same source code file for the library, the same source code for the test suites are being run in every possible combination of Angular and TypeScript and Node.js dependencies, and a bunch of related Angular dependencies as well, like RxJS and yeah, some other ones. So our solution runs at job in GitHub Actions per combination of dependencies. So instead of having 30 projects, we have 49 jobs being run every time we make a PR commit. And we have some Node.js scripts to support that, which are in the tools folder. So we have in total 50 different CI jobs being run on every commit. 49 of those are in GitHub Actions. We are an open source project, a public repo. So we have unlimited usage of GitHub CI runners. And between 10 and 30 of them are running in parallel at the same time, depending on the time of day and and resources available in GitHub. The whole CI workflow takes around 6 minutes in total. That's pretty nice for all that it's doing. And we've optimized that a lot, of course. As you can see on the right-hand side, there's one job, the build job, where 3 of the other job categories depends on that build job. So of course, it's also about keeping that as fast as possible. What the jobs do, we can have try to get an understanding here. The build job is a production library built with the Angular CLI. It uses the latest versions of Node.js, TypeScript, and Angular, the latest combination of those dependencies that's supported. The lint job checks the formatting and linting rules, also using the latest versions of dependencies. The sonar job generates test coverage and lint reports, then it uploads them to Sonar Cloud. So this is the first of the jobs that depends on the build job. So here we're seeing what's called a CI matrix. So that's the combination of dependencies. Here we're just using one version of Node.js, the latest major version supported by Angular CLI. But we're testing 8 different versions, major and minor, of Angular, and all the TypeScript versions that go together with those versions of Angular. So we have, let's see, we have 8 matrix legs being run here. What's happening in each one of those job runs is first it installs Node.js 12, then it installs the Angular version for that job, and then the TypeScript version and other dependencies that are related to Angular. And now it goes and runs all of the unit and integration tests for our development projects. We have some testing utilities. The library packages themselves also have tests, of course. And even the schematics have units and integration tests, as well as those end-to-end tests that are run in another job. So 8 different runs running the same source code and the same test code, but with different versions of Angular, and each one being run in isolation. We also have our app job. That's the demo application project we saw earlier. So that also has some unit tests that are being run with 2 different versions of Node.js, 8 versions of Angular, and 5 versions of TypeScript. That gives us 16 matrix legs. So it'll run, it'll install either Node.js 10 or 12, and then all the different versions of Angular and TypeScript again. Now we have to do some setup here. We're using TypeScript. So there's a path mapping, which means we can, from the application, we can import add ngworker/lumberjack, but it would pick it up from the local source files instead of the build package. So we're deleting those path mappings from our configurations for TypeScript. And then we're downloading a build artifact from the build job. That's the package that will end up on NPM. We're taking that down from, we uploaded it in the build job, and now we're downloading it in GitHub. We take that package, we unzip it and move it into node modules, and then we run what's called the Angular Compatibility compiler. It's a temporary solution because Angular is switching from Vue engine to Ivy and a rendering engine for Angular, and the libraries are still not able to be compiled to Ivy yet. So it's a temporary solution, but it's important to also test this part on the actual bundle that we're outputting. So now with all this set up in each of the jobs, and now they can run the demo applications unit and integration tests, and it will also do a production build and ahead of time compilation build of the demo application, which will of course make sure that all the TypeScript types work together in all the different versions and all the different versions of Angular as well. So that was the app job. We also have an end-to-end job. Same thing as before, all these different versions of Node.js, Angular, and TypeScript and related dependencies. Has 8 matrix legs, the same setup as before with the build artifact and the compiler being run. Then it installs the latest version of Google Chrome, since we're using Protractor. And now it runs the end-to-end tests for the demo application, but does that with every single version of Angular and TypeScript. The last job we have is the Schematics end-to-end testing project. It runs with both versions of Node.js that are supported. Every version we support of Angular except for version 9.0. And it was because some incompatibility with Jest, the version of Jest we're using, and Angular 9.0. For some reason, it doesn't work here with end-to-end schematic tests, but we have version 9.1, so we're still pretty comfortable. It also works with 9.0 since there should be no breaking changes. So what's happening in the end-to-end job for schematics, it's the same as before with all the setup and compilation. But then we run our end-to-end test for the schematics, which would run the commands using Node.js and see how the code was changed by those schematics. The 50th job we have is running Sonar Cloud. Sonar Cloud has an open source license, so we're using that for free as well as a public open source repo. It allows us to set up what they call quality gates, so we can have a threshold for test coverage and all these metrics they provide here. They call it bugs, vulnerabilities, security hotspots, and code smells and duplication detection. So we can set up quality gates for new code and for the existing code. And each quality gate can be associated with what they call a quality profile that provides additional lint rules maintained by Sonar source, metrics called cyclomatic complexity and cognitive complexity analysis. So the image you saw was a comment we will get in from Sonar Cloud in our pull requests on GitHub. So it will break the build if we have any bugs, vulnerability, security hotspots, or code smells, or lower than 85% code coverage in logical branches, functions, and lines of code in the PR. And I don't remember if we have 0 or the default is 3% duplication allowed, but we have managed to keep it at 0%, and we're at 99% test coverage overall, and 0 bugs and so on detected by Sonar Cloud. So that's a pretty nice tool to also keep our code quality and have metrics on it over time. So that was our CI job. And now let's look at how these matrices are configured in GitHub. If you have set something up on GitHub before, even if you're doing it in something like Azure DevOps, you know that there will be an action when using GitHub or a task when using Azure, for example, to set up a specific version of Node. So you might have seen that before. You might not have used the matrices, but that's when you can run the same job multiple times, but with different versions of Node, for example. But when you then combine that with all the different versions of Angular, that's when you get 14 different matrix legs, for example. So this is actually a GitHub action we created, the Angular versions action. The one for Node.js is created by GitHub themselves. We created this one specifically for this library to solve this problem. So that's the one that accepts the versions of Angular we want to test. And what it does is takes the input parameter with the version of Angular we want to support. It then goes in that job run, it replaces Angular and its related dependencies such as TypeScript and package.json, but that's in isolation in that job run. So it's not committing anything to Git or something like that. And we have tested and verified that all the different combinations of dependencies are still in a working state. Because sometimes, with node modules, dependencies of dependencies, they break at some point if you go back to older versions. But we have found working combinations of dependencies with everything related to Angular and TypeScript. So yeah, that's very neat if you're maintaining an Angular library and want to have a setup similar to this one. You can reuse this Angular versions action. It currently supports Angular CLI, but we're also looking to support the NX CLI for Angular projects. Lumberjack also comes with some classes following the builder pattern, and it has some conventional declarative APIs that we recommend for structuring your logs. So this is the example from earlier where we saw that to use this Lumberjack service, we had to pass a timestamp, and to support testing, we would also have to inject the Lumberjack time service. That's not really convenient, except when you need to test it. But we can hide that away by using another service called the Lumberjack Log Factory. That follows the builder pattern. So instead of these object literals, now you have this service that has a method per log level. So for example, in the first one, we're creating an error log with the log message of failed to save the hero. It has the scope property to of heroes app, heroes feature. Then we call build, which will output the log object. And that is then passed to the log method of the Lumberjack service. And we see the same with the info log level. The only difference is we're calling create info log, and then with scope and build. So that's a bit of a more convenient, and yeah, it's following the builder pattern. So you don't have to guess which properties you need until TypeScript is happy. But we recommend using these logger services. So those are base classes provided by Lumberjack, and Angular is all about classes and services. So you will create, for example, the heroes logger service. It will extend the scope Lumberjack logger class. When we then define this scope property, we can reuse scope as part of those log objects that are being created, and we can reuse that. So it's a bit of code deduplication. There is also a base class called just Lumberjack Logger. It doesn't support the scope property, so you have to add that to the using the with scope method like before. But then you'll have the duplication if you want to reuse the same scope for your log objects. So when you're extending this base class, the logger base classes, you can get a method, a logger method, for example, the hero saved, and it also follows this builder pattern. This time it's called create info logger because it's returning a function. The function will be saved as a method on this class. And when you call it, it will do all the work of calling lumberjack service.log and passing it this log object that's representing by this pre-selected properties, the log message, the info log level, and even the scope here. But the timestamp will be at the time you call this method. So even though you have the other properties set up ahead of time with this builder pattern, the timestamp is still being generated and it still supports replacing it in tests so that you can control these timestamps. And of course, the difference between the two is called create info logger or create error logger, and there's one for the other 4 levels as well. When we're using a logger service like this in Angular, like before, we're using a constructor injection. So we're asking for an instance of our class, the heroes logger. And notice at the top, now we're importing from our own class. So we don't have direct dependencies here on Lumberjack itself. So technically we could replace Lumberjack without touching most of our application code. Just had to implement the heroes logger service and the other logger services with a different logging provider or library. So we're asking for an instance of this heroes logger, and now see here when we're using them, it's as simple as calling a method. And we don't have to define all the log properties here because they were defined ahead of time. We call the method here. We can also convert it to accept a parameter. If there is something dynamic about the logs, their content, we can also do that. But yeah, this is our recommended way. Let's see what all of these decisions and designs give us. The plugin-based architecture, if you remember, all the dependencies are pointing towards Lumberjack. This means that most of your application code, except for that app module, but all the services and components using Lumberjack, they won't have to change when you're adding or changing your logging configuration or your logging providers. Lumberjack comes bundled with the console and HTTP log driver. So you have the most used one, the console driver, and you have a simple one for HTTP. But you can also use the community third-party log drivers, or you can build a custom one by implementing an interface and providing it for Angular. And because every log goes through Lumberjack, we have this built-in error handling we discussed earlier, and we have fast log processing because the log drivers will have to finish fast and don't block, so that we're not interrupting the main thread when going through the application. Our cross-version compatibility with Angular, implemented using GitHub workflows and GitHub Actions. It allows us to have a simple single code-based solution. We have this purpose-built GitHub action for managing the Angular dependencies, which can be reused in other libraries. We have this fast parallelized GitHub Actions workflow where we we're really happy about GitHub sponsoring open source projects, or this would be very expensive. But each combination of the dependencies is run in isolation, both for all the unit and integration tests, all the end-to-end tests for the demo application, and even for the schematics end-to-end tests. This allows us to release features and patches across 8 Angular versions, 6 TypeScript versions, and 2 Node.js versions from the same single code base. So there's nothing in the source code about this version or that version of Angular or TypeScript. There's not different branches. We don't have a project per version of Angular we support. So we have just as little code as possible. And then we have this complex CI workflow instead. This is a really nice way of working because every time we're trying to use an API that's not backwards compatible, or some TypeScript syntax that's not backwards compatible, its usage is not detected locally, but it will be immediately within 6 minutes by the CI, GitHub CI, and it will tell you exactly which combination of dependencies has that issue. So verifying support for new Angular, TypeScript, and Node.js versions is usually as simple as adding a value to one of these list parameters in our CI workflow. So it's a very convenient way of working for a library maintainer, and we have a high level of confidence in the code we ship. Even though it's a bit unusual to support many versions of Angular with the same major version of your library. Many Angular libraries will publish a version, a major version of their library that only works with one major version of Angular, at least officially. So Lumberjack has these building blocks for creating a structuring log. So it's a solid foundation, and then it's up to the application developers and the log driver authors to put the pieces together. And Lumberjack will manage the complicated parts of filtering, configuration, and all of that. The logger services in particular are nice because they are conventional structuring of logged system events, which means you have a good overview of which events are logged in your system, and you can test them. And they encapsulate all these implementation details about the timestamp and the Lumberjack service. So they work as an abstraction layer between your application and the Lumberjack logging systems and log drivers. It also means that when you're using them, you can change the logging level, the log scope, the log message, or a static log payload without touching the application code, except of course for the logger service. So we're really happy with that design. So it's one of the new features in version 2 we wanted to release. So thank you for having me. This is my Twitter handle. If you want to try out the library and you're using Angular, you can do ng-add at ngworker/lumberjack. And finally, we have just the logo of my employer, Systemate in Denmark. So back to you, Ayman.
Thank you, Lars, for this nice presentation. Now it's time for the Q&A. I saw 1 or 2 questions in the chat already. So Tushar was asking, is it possible to call log method with message only, which would use default level and time internally, or created at and level is mandatory to pass?
I'm trying to find the chat here so I can read the whole thing.
Yeah, I asked it before and later you mentioned about scoped logger. I think we can use that, but yeah, you can elaborate.
So you're right. The message, the created at time step and the levels, they are mandatory, but we have ways of dealing with them easier. Of course, you can wrap the Lumberjack service in your own service if you want to use some default properties, if you want a simpler API. But then you lose some of the power of having all these logging levels and the scope to group them. But yeah, it's meant to be customizable and extensible, and not be too opinionated. So we offer various APIs depending on your needs.
Okay, and if I use scoped Lumberjack logger, in that way, I still get all the good parts of the Lumberjack, right? That you mentioned,
Yes,
like filtering, etc.
exactly. So you get all the benefits of Lumberjack, but you don't have to worry about all those properties inside of your components or services or wherever you are logging from. So you can predefine it in this this logger class, which is only about structuring your logs.
Okay.
And then you call those logger methods from your services or components, and it will allow you to change the message and so on later without changing the services or components that are calling them. So it's also a way to separate concerns. All the logging concerns are encapsulated in those logger services.